So, my name is Eli White. I'm the CTO and founding partner of Musketeers Me, but more importantly, we are the owners of the PHP Architect brand, magazines, you can come pet them afterwards, conferences, etc. But today I'm here to talk to you about web security. And there's a lot of stuff to talk about, so I have a lot of things I'm going to try to get through. I'm going to hopefully make it within the time limits so that the folks here don't start beating me over the head and telling me the next person has to come in. But especially at the end, if you have questions throughout, please feel free to ask up on them. At the end, if you have any questions, happy to answer them, and I'm happy to spend the rest of the afternoon chatting with you if you'd like to. But let's go ahead and try to get into this, because like I said, there's a lot of things you have to deal with web security. And this talk used to be much shorter, but new exploits keep coming out, and I have to keep adding more stuff, and it doesn't quite fit in an hour anymore. So, this is a phrase I have heard stated many times, like security. Do I really need to worry about it? I mean, I've got this little website. It's just my own blog. Who's going to want to hack me? The problem is, it only takes one person. It only takes one bored kid in school with an afternoon of nothing to do who randomly starts hitting IP addresses and finds a known exploit on your website, right? And once one person is in, it's all over. Because once one person has gotten in, once one person has caused some problem, they can repeat that problem for other people. They can use it to attack your users. They can use it to do all sorts of nasty things. Before I get too much further into this, I do want to point out the Open Web Application Security Project, otherwise known as OWASP. They're at owasp.org. It really is one of the best resources for going online and learning about especially new exploits as they happen, new attacks as they come out. It's a great place to learn about them. I will give you a grain of salt, however, on using it as a resource to find solutions to the problems. It is a wiki-based solution. Anyone can go in and start editing and adding stuff. If you would like a laugh at some point, read through their PHP best practices cheat sheet that they have. It starts off with don't use PHP, and it gets worse from there. So yeah, it's take it all with a grain of salt, but it's a great place to learn about what new attacks are coming out and what issues there are in web security. And one of the first things I want to do is to sort of clear the air on things that aren't really security flaws, so to speak. I guess in the way they are not security attacks, though. But they're just really stupid programmer errors, and we've all done these. I know almost every one of these, maybe all of them, I don't know. I've done at some point in my career, right? I've been doing this for 20-some-odd years now. I have to hide the white hair when I can. And you're going to make one of these mistakes, right? So we do need to go through them real quick. So one of these is having unchecked permissions. So specifically, I'm talking about here, the biggest problem usually is having direct URL access to a protected file, right? So let's say you have a website. You have this wonderful PHP-based website. However, also, you of course have some image files, and maybe one of those image files or a PDF that you serve up is actually some sort of classified document, something that people shouldn't see unless they have the authority to see it. But if that's sitting on your server as a raw media file and someone knows the URL to it, they're going to access it. It does not go through the PHP at all. The fact that the URL allows you to directly access anything, if you allow that to happen, people have access to any media file on your server. Your PHP did not run, whatever programming language you were using, did not run to stop people. So the solution to this is either to use the HTTP level authentication stuff, which is really ugly, or more importantly, just simply don't ever do this. If you have a file that needs to be protected, never let it be served directly by Apache or IIS or whatever your server is. Only serve it through a PHP script. Your PHP scripts can serve images out instead of HTML out. That's not a problem. Have a PHP script that checks the permissions of the user, makes sure they should have access to that file, and then returns the graphic or returns the PDF to them. Another unchecked permission issue is the ability to URL hack to access unauthorized information. All right? URL hacking is just a phrase for going up into the URL and going, oh, there's something interesting there. I wonder what happens if I would change it. There was a major issue that happened, it's it's been a while now, I want to say it was probably like 7 years ago or so in the US, where a bank had this problem. With this bank, you would log into your bank and you got a URL that looked just like this. If you can't see it from the back of the room there, this is like /mybank.com/account/123, etc., your account number. Somebody noticed that fact. They noticed, wait, my account number is in the URL. What happens if I would just change that account number after I'm logged in? They saw someone else's account. They had built in permission checking to make sure, is this a logged in user? But they forgot to do the next step and go, oh, and should this user have access to this URL? You know, they only ever redirected you to your own account, so how would they ever find another account? And millions of accounts got accessed and information stolen because someone just started by hand changing a number, downloading the info, changing a number, downloading the info. Don't do this. Something else I want to mention are information leaks, and specifically in PHP, what I'm usually talking about here is having visible error handling. You should, of course, have error handling turned on your development sites. Visible error handling should never be turned on your production sites. If a visible error handling is turned on, you get an error like is in red down here on the bottom of the screen where an exception happened. And so PHP very helpfully prints out this unhandled exception, exception number, unable to connect to this, and gives all sorts of information. Now, directly speaking, the fact that, okay, so you know that I use a database, and here's the path to this database file, and here's the line number it was on, and here's the function method call that happened. Directly, is that really a security issue? Not per se. The problem is, it's information you've given someone who's trying to hack your system. The more information you give them, the more possibility that they can use that information to use one of these other attack vectors we're going to talk about here in a minute to find a hole in your system. It can be possible that just by having the error handling, for example, exposed, lets them know what framework you were using. And maybe they know even what version of that framework because of that error handling. And maybe there's a bug in that version of the framework because you haven't been updating to the latest versions. Always do that. Something else I want to bring up is having low security hashes. All right? If you are doing hashes for any purpose, be this for your sessions, be this for passwords, be it for any reason you are creating a hash, and passwords are the most common thing, please, please, please use a highly secure one. Do not use MD5. It's amazing how many times I've gone and looked at people's code bases. I get brought in to do a security review, and their passwords are stored as just MD5s. MD5s are amazingly easy to break using modern computers. This laptop within a couple hours could probably break, if I was given someone's password database with MD5s, it could start figuring out at least some of the people's passwords. Specifically, probably the people who have password, but once you figured that out, you can then start walking through them all. And one of the problems with using MD5s is that there are things called rainbow tables. How many people in the room know what a rainbow table is? Oh, good. All right, for the few who didn't raise their hand, a rainbow table is a reverse lookup for a hash. They can never be complete, but they can give you the most common things. So you can go online, you can Google for an MD5 rainbow table, and you will be able to paste in a hash, and it will go, oh, here's common things that hash to this value, such as root, such as password, such as My Little Pony. Whatever someone decided to use as their password, and that's what comes up. To fix the fact that rainbow tables work, you should always salt your hashes. Salting your hash is a terminology to mean simply adding something else to the password, in this case, before you hash it. So if, for example, before every password, before you save it, you add PHP to the front of it and UK to the end of it. So if I enter my password as password, my password really becomes PHP password UK. Now you have broken the ability for someone to use a rainbow table to affect if they ever got your database. Because PHP password UK is not going to be a common thing that would be in a rainbow table. Someone would have to now make a custom rainbow table just for your website. All right? So just adding a salt does amazing amounts for your security. But really, the moral of this story is do not use MD5. There are so many better hashes. They're all available in PHP. Look for the hash extension. It's built in. SHA-512, SHA-256, Blowfish. There's a bunch of great algorithms you can use. The latest version of PHP now even has its own password hashing separate extension that takes care of using the latest hashes for you and even handling upgrading users to better quality hashes as new versions of PHP come out. All right? So let's go ahead and move into now. We're beyond the stupid programmer errors. Let's move into the true attacks that you simply have to be prepared for. Probably the most common of these that most folks will already be aware of, but if you're not, you're going to find out very quickly here, is SQL injection. This is simply the idea that a user can give you information that will be directly interpreted by your SQL engine, right? It gets more specifically, it gets interpreted as SQL itself. So the security hole in this case is as simple as taking direct information. We have here select star from users where name equals, and we have $post name and password equals $post pass. You have taken that information from the post, from the form submission from the user, and have directly put it into a SQL query. Now, all someone has to do to attack you is enter a funny-looking name or even a funny-looking password. So they could now enter, for example, their name as tick or 1 = 1 semicolon. When that gets injected into this, it becomes select star from users where name equals tick tick, so blank, or 1 = 1 semicolon, the rest of the line doesn't matter. They have now logged in as anyone without knowing the password. And depending on how your code's written, they probably just logged in as the first user in the users table, which is usually your root, your admin user, because that's what we all end up doing. The first thing you do is you create your admin user, so they're user number 1, or 0 if you like to count from there. And suddenly they just logged in as admin without having to do anything. They could change that to be where the username is whatever user they want to log in as, or 1 = 1, and they have again removed the need for the password. There are 2 solutions to this. The highly suggested solution at this point in time is to use prepared statements. Prepared statements, shouldn't ever say every. Most modern SQL engines support them. MySQL, Postgres, Oracle, et cetera, all do. And they're a way for you to hand the database engine, here is my query, with placeholders for where data will be. And then to say, here's the data. By doing that, that data can never be interpreted as SQL itself. You can never have a tick mark to escape something out. You can never say, or 1 = 1, right? So you do this by, this example uses PDO. So you're doing PDO prepare, and you are making this same query, but it's now select star from users where name equals ? and pass equals ? And then you say, I'd like to execute this, and you pass in an array with the name and the password. Now, even if someone does do that, tick or 1 = 1, the database will actually look for a username named that, and there won't be one, and so they won't be allowed to log in. It will not get interpreted as SQL. The other solution is to escape the values, and then you can still put them directly into the SQL statement. With PDO, you do that via the quote command. If you're using the MySQL library, there's MySQL real escape string, but I highly recommend you use PDO because it keeps up to date and does a lot of stuff for you. In my opinion, the only real reason to be using quoting instead of prepared statements at this point in time is there are a few things you cannot do as a variable in a prepared statement. For example, if you're trying to pass in what table name you're wanting to select from, you can't have a question mark there. So if you are somehow taking data from a user and using that as the name of a table, the first answer is refactor that. You should not be doing that. But if for some reason you are, the only way to protect yourself would be to escape it, to quote it, instead of trying to put it in the prepared statement. Now, there are other types of injections similar to SQL injection. I'm not going to go through these all in detail because hopefully you don't have any of these problems in general. One is command injection. Like with all of these, it's the idea that a user has given you something that you are now interpreting as not just data. So in the case of SQL injection, you are interpreting that data as a SQL command. Command injection is if you are doing command line work from within your PHP. They give you some information. You somehow, for some reason, decided to put that in the command line. And now they have managed to execute something on your machine by escaping out your command and running whatever command they wanted, like cat etc password, and now have your entire system password file. The most common version of this I see is when you're allowing people to say upload files. It's a common thing to then use command line tools from within PHP to like resize images, right? Someone uploads an image and you're going to crop and resize it to 150 by 150. You could do that directly in PHP, but it's kind of a pain. So you just hop out to the command line and use some shell tools to make that happen. You have to be prepared that they might upload the file name of their file. If you trust that file name, they could actually do an injection on you on the command line by just how they named their file. You can't trust anything you get from a user. You have to assume all of your users are evil and out to kill you. Similarly, unchecked file uploads. This is simply if you are allowing someone to upload a file. Say you're having profile pictures. It's one of the most common things, right, is you allow people to upload a profile picture for their account. Make sure that it's actually a photo when it's uploaded. Make sure that you decide what your allowable formats are, JPEG, PNG, GIF, etc. Check and make sure it's actually one of those. There are tools in PHP that allow you to inspect the file and figure out what MIME type it actually is and to know, yes, this is actually an image. Don't allow them to upload anything and go, okay, and now they've uploaded an executable. Now, the fact they upload an executable doesn't directly mean they can run the executable, but what if they can upload the executable here and then they find a way to do command injection and can now run the executable? So many of these attacks end up working in conjunction. Finding one hole leads to another, which leads to them having a way to really cause major harm on your server. And the last one of these injections I want to mention is code injection. This is someone giving you code that is somehow interpreted as PHP. There is only one reason you ever have this security hole. You used the eval function. Don't use the eval function. Eval is only one letter away from evil. Just remember that. All right. So the next hack I want to talk a little bit about here is session hijacking. This isn't directly a PHP-specific issue, but it comes up very often in PHP because PHP provides such a great session functionality that every PHP program in existence now uses it to some degree. And so session hijack attempts become fairly common. And so you really have to work on this. I was the programmer number 2 at dig.com, and we constantly had issues of people really trying to come and try to very specifically become Kevin Rose's account. It's all they kept trying to do. So the idea here is that a user becomes someone else via impersonating them. You impersonate someone else's session, you impersonate someone else's computer, and suddenly you get their session, right? And now you are authenticated as them. Because realize, in the end, unless you do extra work, the way PHP sessions work is that someone comes to you, your PHP says, okay, I'm creating a new session, I'm generating the session ID, it's a hash, I'm going to hand that hash off to you. If you come back to me and say, by the way, here's my session ID, you go, great, I know who you are, and that's it. If you just walk up and say, here's my session ID, and it's someone else's session ID, you're now them, all right? So we have to do some work to try to stop this, all right? And there's a few different ways to do this, all right? I'm going to actually go into some more detail on a couple slides here. So one specific type of hijacking is called session fixation. Session fixation is the ability for me to make a way so that when you visit my evil website, I have a link that sends you off to another website that I'm wanting to attack. In that link, I provide a session ID for you. I now know what your session ID is. Once you've gone off to that other site going, by the way, here's my session ID, I can then immediately, after knowing that you clicked that link on my site, I can follow right behind you and go, yes, here's my session ID, and follow your footsteps and become you, right? There is only one way you can actually perform this attack, and this is if you are using what are known as URL cookies. URL cookies were the old way of doing sessions in PHP before cookies had nearly the amount of support that they do now in browsers. And so in the URL, you would see something like $PHP session ID equals and the session ID. The thing is by default, so many servers, even if you're using cookies, this is still turned on. It still exists as a possibility. It has not been disabled. You need to disable this. There's no reason you should be using these anymore. Every browser in the world supports regular browser cookies. Don't do this. And so the solution is to actually set some configuration items in your php.ini. One of them is use cookies equals 1. And by setting that, you tell PHP, yes, I want to use the cookies. But the more important one, well, they're both important, but just as important, is use only cookies equals 1. And that's the line that tells PHP, and don't ever allow a URL like that to work. Don't ever look at the URL get parameters and assume that's a session ID. Once you've set those two things up, it is now not possible for someone to do a session fixation attack, right? The other thing you should do, though, just to go one step farther, because it is possible for some other more complicated session fixation attacks to happen, such as if I got access to your computer, maybe I actually edit your cookies file and I put a known cookie in there, and then while you're sitting at a conference, while you were at lunch and you weren't looking, not that I did that to anyone. And then you go and visit that website, and again, I now know the session ID that I told your browser to push. So there's some ways to do it. In fact, there could be some man-in-the-middle attacks even, where you happen to be going through a proxy that I've created, and I'm scanning for the cookies and rewriting them, and there's some other type of fixation attacks that can happen. So the one other thing you should do, and this is sort of a mantra to remember, is to always regenerate the session on change of permission level. So if someone logs in, regenerate the session ID. If someone logs out, regenerate the session ID. If someone has logged in, takes an extra step to now authenticate as an admin, or to authenticate as a different level of access of any kind, regenerate their session ID. All right? By doing this, even if I have managed to hack your machine and give you a known session ID, and you go and visit the website and then you log in, oops, you have a brand new session ID and I don't know what that is. I can only step in impersonating the non-logged in version of you, which is not nearly as fun. So the solution to this, PHP actually makes this very easy, is it has session_regenerate_ID. That's really all you have to do. I highly recommend you put true as the single optional parameter it has. What true does is it doesn't just regenerate the ID, it then destroys the old one. The way regenerate ID works is it actually makes a new session and copies all the data over for historical reasons. The old session is still around. If you put the true, the old session gets completely destroyed. So I now can't even step in as you, the non-logged in version of you. I'm stepping in with a brand new session because it looks like a brand new session ID. All right? And do that after they log in, do that after they log out. Just sprinkle it wherever. It really doesn't hurt you to have it in there. It's very little overhead in regenerating the ID. Now, the next thing is when people are not doing fixation but are truly trying to hijack, they're truly trying to come in and attack. And this is where someone is very specifically going, for example, I'm just trying to guess, right? So I'm just going to start sending session IDs. I'm going to edit my own local cookies file, right? And I'm just going to send random session IDs and load a page and see if that page has a little, thanks for logging in, so-and-so, up in the corner. Right, because most websites, you have a little login button, and when you're logged in, that changes to like an account button or a logout button. And so it's easy for someone to write a script, just constantly accessing your server, putting in different session IDs, and then scanning the HTML that comes back to see if there's logout versus login up in the corner. And they can just randomly hijack someone's session that way. So there's a few things you need to do. Now, this is not simple, unfortunately. What you have to try to do, and it's not perfect. There's no perfect way to solve this. I'll warn you up the front. You simply have to make it as difficult as possible. So what you need to do is store whatever unique you can about that specific user and about that specific browser, and check that every single time. So for example, if I've been accessing your server using Safari, and the next request with my session ID appears via IE, that's not me, because sessions and cookies are specific to the browser in question, right? So we can check and make sure the browser is the same. Unfortunately, there's not much else we can really check. You could check IP address, but the problem is in the modern, like that used to be good 10 years ago, but nowadays everyone's coming from behind firewalls and corporations. Everyone shows up as one of two IPs, and people even at home, your home internet access, every time you connect or in the middle of connecting, your IP address may randomly change if you're on a cable modem or DSL. So what you end up with is something that looks like this. This is as small and compressed as I could get the code to fit on here. And I won't try to go into great detail on this. I will be uploading these slides to my website after this, so you can kind of walk through this if you want. But basically, the very simple version of this is, and I'll drop down to the bottom here, which I realize the people in the back can't see, but I have just a little bit of code here that generates an anti-hijack token. And all I'm doing is I'm taking their user agent, I'm throwing something random in there, and I'm putting something unique to this session. Whenever a session is started, I store a date timestamp of that session. So someone trying to hijack would also have to know what exact time this session was started, because that's something you can always remember. So basically, I'm taking this random salt, the user agent, and this time that the session was started. I'm smushing them together and hashing them with a SHA-1, because MD5 is bad. And I'm storing that as a token. And I'm going to store that in the session, and I'm going to send it to the user as a cookie. So every time someone comes in with their session, I end up going through this bit of code, and this magical line here that's way too complicated and shouldn't exist. But it comes down to I regenerate what their hijack token would look like from the current browser contacting me right now. I attempt to read the hijack cookie out of the session. I attempt to read the hijack cookie out of the cookies. And basically, all three of those have to be identical. If for any reason any of them are different, it's a hijack attempt, right? Now, of course, the problem is, how many people in here use Firebug? Yeah, you're going to hate once you put this on your website, because Firebug changes your user agent to say, hey, Firebug's enabled, oh, Firebug's disabled, anytime you click the little on-off. And so you'll catch yourself hijacking yourself because your user agent changed, and then you have to log back in. You can actually change Firebug to not change the user agent, but to send a separate header instead, and I highly recommend looking into that, but it's kind of buggy. So, like I said, we can go into that more later. I don't want to hang on this for too much longer, because we've got some other really big attacks to go through here. So cross-site scripting is one of the biggest attacks that happens out there. It's abbreviated XSS. Again, this is a case where the user is giving you something and you are interpreting it as not just data. With cross-site scripting, you are interpreting it as JavaScript, as any scripting language really, but 99.9% of the time as JavaScript. There are tons of ways this attack can come in. It can come in from the forms. It can come in as their user agent. It can come in as random headers coming in. You have to, again, realize that anything coming from the user is suspect, right? Even URL strings, because if you are rewriting, like using mod rewrite in Apache to have pretty URL strings that then get turned into something in your code and turn into a path, the user can put whatever they want in there, and your rewrite rules may pick that up and now allow them to have injected something, right? So the key to fixing this and a few more that we're going to talk about here is to remember the mantra FIEO. Filter input, escape output. You need to filter any information you get from the user so that if you're asking them for an integer, you check and make sure it's an integer, and if not, you don't accept it, right? If you're asking them for anything like that, you check and make sure it's actually what you asked for. And then, the most important part is you always escape output. And really, I love FIEO, but the EO is the most important part. Filtering helps keep your data clean and helps having defense in depth is very important. If you filter out the attack, then you don't have to worry about it as much when you escape. But if you always escape your output, then you will never have that attack, you will never let that attack work. It's good to filter it as well, though, however, because you don't want that attack living in your database, waiting for the day a programmer writes a new piece of code and forgets to filter, forgets to escape. So there are 3 different types of XSS attacks. I want to walk through them real quick. The first is reflected XSS. Reflected XSS is directly echoing content from the user back to them, right? So the security hole in this case is simply having, thank you for your submission, post first name. So someone types something in, and on the page you come back, you just go, oh, thanks for submitting that, Eli. Now I go in and enter my name as script tag, alert XSS script tag. That will be echoed out. That JavaScript will now run. That alert will happen. Now the thing is that this looks like, okay, who cares that I can run a bit of script against myself, right? It's no big deal, right? The problem is it is because users can be very, very stupid. You can trick people into doing anything. How many times have you seen, for example, on Facebook or somewhere else, someone going, hey everyone, try doing this. Type this thing into this field here and see what happens. It's really cool. And people do it. So people can be tricked into like, hey everyone, type this in. And realize, you'll see alert XSS is a very common test for if there's a cross-site scripting thing, because it's something very easy to see when it triggers off. Realize how evil stuff can be here is. If you're running any custom JavaScript, you can read that user's cookies. By reading that user's cookies, you know their session ID. You even see their anti-session hijack token if that was being passed in as well. You can easily now impersonate that person. If you can execute any JavaScript you want, you can actually have your JavaScript do DOM manipulation to make their browser do things like click buttons. And it's not that there has to be this huge amount of script in here, because JavaScript can include external JavaScript files. So all this has to be actually is an include, a script tag that includes a JavaScript file from some other website. And now, not only have they done that, but if measures are taken to try to stop that from working, well, the attacker has the source on their website, and that source gets loaded fresh every time, so they can be constantly updating the attack and doing different things, right? So this is a problem. The solution to this is, again, to escape the output. Now, when you're escaping output, you have to escape it to its use case. So if you are outputting something as HTML, which we were just doing in that last case, we were trying to output something into HTML, you want to use either HTML entities or HTML special chars. They're 2 different functions in PHP. They do very similar things. Entities is just a little bit more OCD about escaping everything. HTML special chars tries to only do the ones that are evil. You simply pass in the data you're wanting. There's a configuration for whether single quotes or double quotes or both get escaped or not, which depend on how you're using it. Sometimes you need to tweak with that. The most important part here is this third parameter, which is the character set. It is very important for you to specify the character set that your data is in and the character set your HTML is being generated as, so that it is escaped correctly. There are very sophisticated, very weird, funky attacks I don't even understand that have to do with tricking HTML entities based upon the various character sets. So like, oh, so you're actually outputting this into UTF-8, but your HTML special entities is only escaping it for ASCII, and so certain characters don't get escaped or get escaped in a wrong way that actually turns them into an attack themselves, and really weird things happen. So make sure you do that. The final parameter, which I have set to false, is whether you want double encoding or not. If you set that to false, if you already had something escaped, if there was already a HTML, a hashtag or an ampersand less than semicolon, it won't double escape that. It won't re-escape the ampersand to be another ampersand. So it makes it safer to just run whenever you want. But that's for HTML. For JavaScript, again, you can download these in the slides later. This is just really some weird stuff to escape it for JavaScript, you do this weird /r/n moving around and add slashes. And XML is not HTML. Trying to run HTML entities and output an XML document, XML will scream bloody murder at you. So there's this really weird, I have no idea exactly what this line of code does. I found it many years ago, and I have cut and pasted it mercilessly since then. It does some really weird trick of converting from a character set UTF-8 to character set UTF-8 ignore, and then doing a string replace, but it works. So you can copy that from my slides when I upload them after this talk. So the next type of attack is called stored XSS. So reflected XSS is when the attack came in, you just directly echoed it back to the user. Now we're going one step farther. Now we're taking data from the user, we're storing it in our database, and then we're echoing it out to the user later. So the security hole, it's very similar. Just now, we're actually saving the database. So here's the case. Look, we're doing the right thing. We've protected ourselves from SQL injection. We're using prepared statements. But we're still just taking the raw data, the post first name from the user, and storing it in the database. Now that user can put any type of JavaScript as their username, and when on their profile page you echo out, welcome to so-and-so's profile page, the attack is there. This is now an even more serious thing, because if I have a profile page and I can change my name to leave an attack in waiting on my profile page, everyone who comes and visits my profile page is getting attacked without me doing any work whatsoever. The best part about this is the solution is exactly the same. You simply escape the output. You should have also filtered the input. For example, calling strip tags on that input. If you're asking for someone's name, you probably don't want HTML tags in it at all, especially not the script one. So run strip tags on it as the data comes in. But as long as you escape the output in the exact same way, that attack is thwarted. You'll actually see the script whatever being output as the person's name. And now there's one other type of XSS that gets a little weird, especially for us PHP folks. How many people in here consider themselves JavaScript experts? That's what I figured. All right. This is DOM XSS, otherwise known as what happens in JavaScript stays in JavaScript. You now cannot fix this with PHP, because this is now, someone is coming to your website, they are doing some interaction on your website. You are reading that data via JavaScript and directly manipulating the DOM with that data and essentially echoing it back out. Right? So I have this example here that if you're familiar with jQuery might make sense or not, which is where you have a form called verify and you have this script that says, well, when that form's submitted, don't actually let it submit. Instead, I'm going to read in the value of the input that had name first, and then I'm going to actually append to the bottom of the body, thanks for submitting this first name. So now you have created the equivalent of a reflected CSS attack, or sorry, XSS attack, right? You have taken data from the user and echoed it back to them, but this never touched your server. You couldn't solve this via escaping in your server, because it never comes there, right? It's all in the JavaScript. So there is one solution to this, which is called never do this. You could always round trip any information to your server and have PHP echo the data back in a Ajax type response and then put it back out. But more and more often, so much of these applications are being written purely in JavaScript or with very small backends, so you don't really want to do that. So a simple solution to this is something like this, and yes, I call this simple, because the problem is JavaScript doesn't have the equivalent of HTML entities. It does not have any good way built in to solve this. Some future versions of JavaScript that are being worked on have some potential ways that are going to be built in to do it. This is what a simple function could look like that just walks through the string and looks for, does kind of the equivalent of HTML special chars. It looks for less than, greater than, quote, double quote, and turns them into their HTML entity equivalents. The thing is, though, you shouldn't do this. Because escaping something for whether it's HTML or whether it's a class name or whether you're writing CSS on the fly or whether you're taking stuff and using JavaScript to generate more JavaScript on the fly, all of these different ways you're using the data all need escaped differently. This won't work for all of them, and that becomes a problem. So what I really recommend is there's a library. Again, this will be on the slide so you can't read it, but it's github.com/chrisisbeef. I'm guessing Chris is a cow of some sort. But chrisisbeef/jQuery encoder. It's this great jQuery plugin that gives you ways to handle escaping all of these different ways, where you can just make a call to this jQuery encoder and say, I'm using this as CSS, and it escapes it for you for CSS. I'm using this as an HTML attribute, it escapes it for that. I'm using this as an HTML class, it escapes it for that. And it makes it very simple, and I highly recommend you take a look at that project. So the other attack here is cross-site request forgery, or CSRF, also known as CSRF, because that's a really big mouthful to say all the time. And you can imagine the attackers being from California and doing their little sea surfing thing. All right. So this is one of the first cases where it's an attack where it's not that the user's getting code they're submitting to be executed on your server or on someone else's computer. This is an attacker forcing or forging a request from another user. Right? So I'm going to somehow force you to make a request when you didn't think you were. So there's a couple ways to do this. One of the simplest ways is simply using image tags. So you're going to come to my website, and I'm going to have an image tag. And I'm going to make this image tag have width 1, height 1, because it's not really going to work. So I don't want you to notice that it appeared. And the source, however, of this is going to be a URL to another server. When you visit my website, I force your browser to make a request to another server of whatever URL that is. One well-known security hole like this, which the company has been informed of but refuses to do anything about because they think it's okay, Amazon.com. It's possible to generate a URL that will add a book to your shopping cart. So I've known a few book authors who, on their home pages, you visit their homepage, and when you happen to go to Amazon next, if you were logged into Amazon, you'll notice their book is sitting in their shopping cart waiting to be bought. Now, Amazon feels that's okay with this because they sort of like it as a feature. They've closed the security hole that you can't actually make the person buy it, right? You can't make them check out. But given that Amazon shopping carts, they store whatever you put in them forever, it does make this possibility that you might by accident rush off to Amazon real quick, add something else to your cart, check out, and not notice that there was this extra book sitting in there. That's the simple version. The one catch with using like an image tag like this, of course, is it can only be a GET request. If there's any parameters that have to be created, they have to be a query string kind of parameter. If you want to forge or force a POST request, you're going to have to use JavaScript. And again, that's actually ridiculously simple to do because you simply visit someone's website, and this is a little bit of jQuery that simply says, post to this URL this data. And again, you visit my website, and now I force your browser to go off and post data to another website. You had no idea your browser even did it unless you had your network activity logs up and were watching it. So, this is obviously a problem. So the solution to this is a little more complicated than some of this other stuff. This is only half the solution here. The solution in general, let me describe it here, is the solution is you need to come up with a way of knowing that this particular user, that user was the one who truly made that request. This was not a forged request. This was not a forced request. The way to do this is to give that user a specific piece of information that only that user who came to your website knows. Someone from another website forcing the attack doesn't know. And we do this, we call them CSRF tokens. There's other terminology for them. If you happen to use WordPress, WordPress calls them nonces. Whatever terminology you want, it doesn't matter. So this is the solution for on the form. Basically, you're going to have a function that generates a token, and literally all it's going to do is generate some completely random token. You'll note this one is actually MD5, but that's kind of okay in this case, but you could make that SHA-1. But this is just a standard, the MD5 unique ID MT ran true. That's one of the standard, like, give me just a completely random nonsensical key of some sort that's going to be a one-time use thing. So you're going to generate this token, and you're going to save it in the session, and you're going to echo it out as a hidden form field on the form. All right? So this is now kind of getting like those anti-hijack tokens we did before, but this is based on the form. So you've generated this token, you've handed it to them on the form, and you've saved it in the session. Now, when a form is submitted to you, you're going to look and see, was there a token in the session? Was there a token posted to me? I'm going to regenerate the token as well and make sure that all three of these again match, right? If I am on my website trying to put an image tag to link off, or I'm trying to do some JavaScript to make you post off, I have no idea what uniquely generated token you would have loaded when you loaded that form. In fact, given that you hadn't even visited the website before that form magically got submitted, you don't even have the token in your session. So the fact there isn't even a token in your session means it's going to get declined in the first place, right? This is a little bit magic, but it works. There are also lots of pre-built solutions to this. Like I said, I mentioned WordPress has nonces. Almost every framework, PHP framework out there has some way of generating these built in. I highly suggest you use it. And there's one more really, really evil attack I want to bring up. And I say this is one of the newest threats. It's been around a while now, at least 5 years. I think it was about 5 years ago when Twitter got hit with this. This really came into the scene when Twitter got hit. If you were around at the time and you happened to be a Twitter user, you would have noticed suddenly for an entire day, Twitter was flooded with everyone you knew, including yourself somehow, posting this exact same phrase. And I even forget what it was. It was like, click here to check this out, and it was a link. And when you went there, you went to a website that had a, click this button and watch what happens. And you click the button and nothing would happen. And so you'd click the button again and nothing would happen. And you go, huh, that's weird, and you'd leave. And later you'd magically see that, hey, why have I tweeted a couple times? Click this button and see what happens. And it became just this viral attack that was happening. What the trick is here is it's a way to get around CSRF protection. Because CSRF protection only works, the only way it works is because I'm forging a request. I'm forcing your browser to go off and do something. If you can instead trick the user into actually loading the page and actually clicking the button without them realizing that they've done it, it was a valid request. The user truly did load that page and click that button. Now, it's kind of hard to explain this purely in text, so I have an example, a little demo here to show you, because I think this drives it home a little better. So here's this website I've created called evil.example.com. And welcome to this website, and has, why don't you click my button? Now, this button doesn't do anything at the moment. But now what if we say there's this other website called Quacker that lets you post whatever you're thinking about at the moment? All right? Well, let's take this website, and instead of having it separately, let's put it inside an iframe on our page. That's perfectly valid. You can iframe any other website you want. But now what happens if we take this, and we take this Quack It button here, and what if we moved it so it was right over top where that button on my website was? And now let's go one step further. What if we took that iframe and made it disappear by setting its opacity to 0 in CSS? It's still there. It's 100% transparent. You cannot see it's there, but it's here. If you click anywhere in this area, you are not actually clicking this web page. You are clicking the remote website through the iframe. And so now, when I go and say, I want to click that button, nothing happens. because you didn't click that button. You actually clicked the button in the iframe on the other website. Your browser loaded that other website into that iframe. You physically clicked the button, even though you had no idea that you did it. Evil. So there is a simple solution to this with a huge drawback. So the simple solution is that there is a header that you can set. Have your server set this on every single request going out. You could configure this in Apache. You could do it in PHP if you need to. It's called x-frame-options. You can set it to deny. If you do that, it tells any browser, my website should never be in a frame. It should never be in an iframe. It should never be in an old-style frame set. Do not let my website appear in a frame. And the browser will respect that. Because this attack relies on you being in a frame. You can also set same origin, which means it's okay if I frame myself, like if you're doing that on purpose for maybe you have your own internal ad server and you're serving up ads in an iframe or something. If you have a valid use of it, you can say same origin. You can also say allow, but you should never say allow because that means please attack me. The problem with this is it doesn't work in all browsers. It only works in modern browsers. So someone using a slightly old version could still be attacked. The one thing that is great is in October of 2013, this started as, prepare to hold your breath, Microsoft and it was Microsoft and Google actually got together and they decided this was such an important problem, we needed a solution. The two of them got together, came up with this concept, and instantly implemented it in IE and Chrome. Of course, Firefox and Safari didn't have it. But in October 2013, the IETF approved it as an official standard. It's now RFC 7034, so it is an official internet standard. And so in the future going forward, all browsers should support this, and all modern browsers do now. There is another solution if you absolutely want to protect yourself, even if someone is browsing you with Netscape 4.0 or whatever. It's kind of evil, though. What it is you're basically telling your website to never let itself be displayed in a frame itself. But the only way you can do that is, so you make a CSS style that says body display none. So by default, your website will not display itself. The CSS says it will not work. Then you have this script at the very top of your body that says if self equals top, which is how you check if you are in a frame or not. If self equals top, then everything's okay, so I'm going to, via JavaScript, select the body and tell the body you can now display yourself. Display style is now not none, it's now block. Otherwise, I'm going to redirect myself. I'm going to set top.location equals self.location, which breaks you out of one level of frame setting. So if you're multiple levels down, each time you're loaded, you'll pop yourself out one at a time until you're at the top of the browser. Obviously, this is a major hack to fix the attack because this will actually make your website flash, especially on low connection, because the website will load with the display being off, then the JavaScript executes, it then decides, oh, I can display it, and so now everyone loads your website and they get a white screen and then it flashes on. They get a white screen and then it flashes on, like with every click all around your website. So it kind of sucks, but it works. I have seen people actually do like Apache-level browser detection to say, if this is a browser that I know supports the X-frame headers, send an X-frame header. Otherwise, actually force this to be output into the pages. It's all a little icky, though. I'm running out of time here, but there's a few other things I want to go over just real quick. One is brute force attacks. All right, so this specifically happens with passwords. People coming in and just really trying to just try every password possible, either by hand or via a script. There are two primary defenses for this: CAPTCHA or IP rate limiting. So for CAPTCHA, I highly recommend, and I won't go over the code at the moment because I am running a little long, but I highly recommend you look at reCAPTCHA. reCAPTCHA, it started as a separate company. It's now owned by Google. It's a Google project. It's a very easy-to-use free system for doing CAPTCHA. And More importantly, you actually help translate or OCR, essentially, old books in the process. Because what they're actually showing you is from the Google Library project where they've scanned in things that OCR failed on. So since OCR failed on it, a computer can't figure that out. So therefore, they can present it to you. And what happens is whenever these two words are submitted to you, reCAPTCHA only knows what one of these is. The other one, it's still trying to get translated. And after enough, like something like 10 people or 100 people all translate whatever that is, the same way, it goes, oh, that must actually be what that word is. And you never know which one it knows and which one it doesn't. So you're actually doing a little bit of social good by adding this to your website, and you're not having to build your own. And if and as people figure out how to break this, they will find ways to make it better without you having to do the work. That's what the server level code looks like. They have really good docs on this. If you go to developersgoogle.com/reCAPTCHA, there's really good documentation, and it's a really easy to use PHP library. The other thing, and again, I won't go into the actual code here, but you can see it on my slides later, is the idea of rate limiting. Rate limiting is simply the idea of saying, I am only going to allow, for example, so many failed login attempts, or even so many attempts to log in from, say, a certain IP address within a certain period of time. What this is really good for is either setting it to this ridiculously fast rate so that you block bots, so someone can't be using a bot, they have to manually be trying. Or when I was at Dig, we did this a lot for things like people who would go to a page and just start clicking thumbs up on every single story on that page. We actually had the entire team, we got stopwatches out, and we had the entire team look through a page and spend the amount of time they would need to just briefly scan each story and at least make a slightest bit of a mental process of up or down and to click them all. And we timed how quick that was that someone could put a little bit of thought into doing that. And we chose whoever the fastest person was and went, okay, let's subtract even a second off of that to assume there might be someone faster. And that is now our maximum human rate, that someone's putting conscious thought into making this decision and not just someone rapidly clicking buttons. So there's lots of ways you can look at doing this. Again, you can take a look at the code later. So a very brief discussion on server level security. These are really now the true attacks. This talk was focused on the web level of security and stuff that we as PHP programmers can fix. Number one thing that I do want to make sure happens, and please go back to your DevOps or operations departments and show them this slide. Keep all of your software patched. There is no excuses to not be running the latest versions, especially the latest security patches that come out. Having a security hole be announced and patched, and once it's announced and out there that it did exist, all the attackers know, hey, there's a hole, and this is exactly what it is, and it's in this version of software, and I bet I can figure out who's running that version of that software, and I know how to break into them. As soon as new versions come out, make sure you upgrade to them. All right, at least at the patch level. Again, now this doesn't necessarily mean the day PHP 5.6 comes out, you must upgrade to it from 5.5, but make sure you're keeping 5.5 dot whatever always up to date. Although you should upgrade to 5.6 and 5.7. But for DDoS, distributed denial of attack or other attacks where someone is just constantly hammering your server, good luck with that. I highly recommend you hire some really good people. Really, this comes down to looking at your hosting solution, looking at actual firewalls, doing IP-level banning. It gets very messy. It can also get very complicated, and you can often end up banning people you shouldn't. Not that I've ever done that before. But, and the one other server-level thing is the idea of a man-in-the-middle attack. Is there anyone, be honest, who does not know what a man-in-the-middle attack is? Really? Everyone? Okay, at least a couple. At its very basic, a man-in-the-middle attack is simply the idea that I am this computer. I am going to talk to this server. I believe I am talking to that server. However, magically somehow, someone walked into the middle of that conversation. You were actually going through a proxy. Someone, for example, set up a Wi-Fi hotspot, named it free Wi-Fi, and you connected to it. Or you were at a conference and someone set up a Wi-Fi hotspot named the exact same SSID as the conference Wi-Fi, and filtered the request through so it worked. I've seen this happen before. And so everyone was connecting to it, especially on iPhones, which won't show you that it's a different type of device. It goes, oh, I know that SSID, and it just connects to it. And now every request you're making is going through this third party who can see everything you're doing. They can see your passwords going across. They can see all of your cookies, right? There is one solution to this. It's called SSL. That's what SSL was invented for. And that's why you should always have SSL on anything where you are having someone log in, where you're doing any type of financial transactions. As soon as someone is giving you information of any sort of that you need some protection on, you need to do that. And I know Bastian's in the back staring at me, so very brief commercial interruption. Just in case you didn't know, our magazine is actually back in print. We've been out of print for a few years. We found a way to make it viable again. If you would like to come up and pet the magazines, these ones are unfortunately not for taking. The talk I gave yesterday, they stole all the ones I had. But you can come up and pet them. I highly recommend it. Trust me, you'll see why. And again, I think we're officially out of time. Do you have time for any questions, or one or two if there are any? And otherwise, I will be in the back. So, microphone coming over. And while that's going on, please do go on Joined In and rate my talk, please. I would love to get feedback on this, positive or negative. So.
Hi. So I've seen lately a new type of, I think it's like clickjacking or some other kind, where you go with your mobile phone to a website, and with my iPhone, and the App Store will pop up with an obligation to buy something. Have you seen that?
Yes, the question was going to a website and like on your iPhone, and the App Store pops up prompting you to buy something. That's actually not an attack, that's a feature that Apple built in. There's actually code you can put in your web page that prompts that to happen.
But the app doesn't have anything to do with the website.
Yeah, the person who owns that website is just really trying to get you to buy some other random app. Yeah.
So it's on purpose.
Yeah, it's on purpose. Yeah, or they have been XSS attacked, and the XSS is now putting the script in that causes that to happen. Right. One more over here. Oh, got one. One in the back. All right.
Hi. You know this clickjacking solution for the clickjacking 2 solution that you showed us?
Yes.
I don't believe it's going to work if you have nested iframes.
It should. So the question was the clickjacking solution in nested iframes. It should, because. Let me back up to it real quick, if it'll do it. Let's see. Doop, 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 doop. Wasn't that far back, was it? Oop, went back. Because of this, so it does script, it does else top location equals self location, so it will then reload that page again, and then that same code, you'll notice it's still not at the top, and so it reloads it again, and it bubbles its way back to the top. Yep. All right, I think there was one up here, and then I know we need to cut it, so can we just do the one? All right. And like I said, I'll step out in the hallway, and any other questions you have, please feel free, but I know Bastian needs to get going, so.
This is kind of a little bit of a correction to something you said, so I feel a bit scared about saying it, but near the beginning you mentioned salting passwords. What you actually demonstrated was site keys, and you probably shouldn't do that either. The reason being, if two users use the same password, they get the same hash.
Yes.
And if your entire database is downloaded and the person knows the site key, they can still generate a rainbow table. What you do instead is you create a random salt for each user. You can even store the salt with the user,
yes.
Like at the user level. Then the attacker has to make a rainbow table for each user, which is much more intensive. Exactly,
agreed. And that's actually why I highly recommend that you just use the PHP 5.5's new password hashing functions that are built in, because that's exactly what they do. They generate a random one for you. It stores it with the password. You don't even know how it chose to store it, and it can change how it changes to store it, and it's much better, yes. All right, thank you, everyone. Like I said, I'll pack down and walk out in the hallway. So.